and some things that are sitting out there. Is this a problem that's going to challenge you mentally? Is this a problem you spend more of your time interfacing with your calculator than anything else? Type in one variable statistics, done, no partial credit. You put the wrong standard deviation in there, you pick up the S of X, you pick up the sigma of X value. I don't even think you need a partial credit on the test for that because you're supposed to know better. I have to go back and look at our criteria. So maybe a 2-minute problem at the most if you're a slow typist. Another 2-minute problem if you're a slow typist. Now you gotta watch a video. Same video. Same video. Same video. Same video. Same video. I think this one's a different video. Different video. And now we're back to working again. So right there you had 10 problems. You had 8 problems that were videos. Didn't have any real arithmetic work to do. You just had to read, comprehend, and answer the questions. Range. Fairly easy to do from what's on the screen. It's a little hide and go seek, right? Maybe it's beneficial since you have to use the calculator anyway to put it in the calculator and wait to answer the range question until later on. They want the range first, but don't you know what the second question is going to be? Because they told you what B was going to be right away, didn't they? Okay, so calculator. Again, less than 2 minutes. Definition question. The difference between highest and lowest values is called range. Not dispersion. It is a measure of dispersion that has a specific name, range. Okay? True or false? Measures of dispersion are used to describe the spread of the data. The very first statement we made on the first note set screen. Definition. Can you find the range? This is a gift problem. You shouldn't be making mistakes on these. These are free points. Take them and run. Okay? Concept question. Why might the range not be the best measure of dispersion? What 2 numbers are targeted by the range? And those values could be outliers. So we've got a pretty good idea of what to look for in here. Concept question. 2 classes both had a mean score of 73. Class A had a standard deviation of 5 and Class B had a standard deviation of 10. What's the standard deviation tell you? Spread. Who's got a bigger spread? Class A or Class B? Who's going to have a bigger standard deviation? Is that Class A or Class B? Simple. Concept question. Did an exercise like that, didn't we? Watch the video. Okay, I'll tell you right now, don't waste your time watching this video because it simply tells you how to find the range. Honest to God, I promise you. Yeah, that's Miss Muller. So she's talking to you about how to find range. And you're going to spend 2 minutes on this video when you already know how to find range. So you can watch this if you want, but I fall asleep if I watch this, okay? Highest value minus the lowest value. I'm not going to waste my time with that. I'm just telling you, can you find the range without having to watch that video? Now you know, and as G.I. Joe says, knowing is half the difference. Okay? Now this one's going to have different problems. A is going to have 3 parts to it, and so on down the line. So range, can I calculate the range? Range is pretty easy here, right? 6. Great. Is the range the most useful value? No. We already decided that, right? Is the largest difference between the mean and any other value what the range is measuring? Range doesn't even involve mean, does it? Okay, so that can't be right. The number of days separating the fewest and the most sick days taken? Sounds more likable. And then we're talking about the mean of the last one again out there. So we got that value, done with that. So now they say, well, okay, then let's actually go find the standard deviation. 2-minute problem? I don't know what the standard deviation is, but whether it's right or wrong, I'm going to do it this way. Let me see. 6, 2, 2. I'm going to take a guess. I'm going to guess 2. See? Made a mistake. Look what it wants me to do. It wants me to do the long way. It's not 2. Okay? I'm going to take another guess. And my guess is not going to be 3. My guess is going to be 2.24. That was not right either. Okay, 3? I don't know. Oh, that's 224. That can't possibly be right. 2.24. Because that was the same numbers I had in the last class. No, actually, I'm just that good. I could look at those and figure out what the standard deviation was. You're right. Okay? So what's the best interpretation of the standard deviation? Represents the sum of all the deviations?
No.
But if I'm doing it by hand, I had to find all the deviations, didn't I? Okay? Since the standard deviation uses the square of the units, it's not easy to interpret. No, it's not easy to do, but it's easy to interpret. Standard deviation represents finding the deviation from each operation, then squaring, then adding them up, but it also involves taking the square root, which they left off. So again, they're giving you something that you would never have seen if I hadn't shown you that formula. So would D be the best answer there? Very likely, okay? And then they say, suppose that 6 was incorrectly recorded, it was supposed to be 60. What's that going to do to the range? Big change. What's it going to do to the standard deviation? Big change too. Okay, so they ask us questions about those things that are concept questions that we could actually calculate if we needed to. Standard deviation measures average spread. If the median value, the middle value, was 144.9, which of the values up there would not be appropriate to be a standard deviation? Negative? Shouldn't be, because all the values are positive, right? So doesn't the average difference have to be a positive number? So negative can't possibly work out of the problem. What else is unacceptable? 1 million? If the median value was 144.9, I don't think that the standard deviation would be 144.9 because it's got to be smaller than the range. Okay, so 1 million's gone. And that leaves you with 6,000 or 50,000. 6,000 might be too small. So maybe it's a toss-up question. 6,000 is the most possible because the negative value is impossible. Values of 50,000 and 1 million are both implausible, not impossible, implausibly, not likely to be that large. It actually turns out the middle value is going to be in there. So standard deviation is not the larger of these two other values, it's going to be the smaller of the two other values in there. But there was no way you could answer, oh, look at that. That was that's the one I said is not right, not the smallest value, the one that's more in the middle. Okay? Typical. Similar question. Range of values 40 to 100. With a mean at 72. Which is the most realistic value for standard deviation? Which 2 do you throw away immediately? Which 3 do you throw away immediately? -5, 0, and 1. Of the 2 that remain, which seems to be the least likely? 11? You're talking about standard deviation. How much range do you have here? 60 units. So you really think that 66 could be the standard deviation? It's got to be smaller than the range. Oh, so maybe in this case it is 11. Because it's the only one that makes sense. It's either 11 or 1, and if 0 is too small, then 1's not that much different. So we're talking about 11. So it isn't always the bigger of the 2. It depends upon what the numbers are that you're dealing with. Here's your comparative one. Look at the first data set. What's its range? $11. Look at the second data set. What's its range? What do you expect about a range of 11 compared to a range of 3 when you start thinking about standard deviation? Bigger range, bigger standard deviation. Smaller range, smaller standard deviation. Comparatively, do they ask you what the standard deviation is? So do you really need to spend your time typing those in to be able to answer that question? Could you if you wanted to? But you're still going to have to be able to compare. The range gives you an idea about what to expect in terms of comparative standard deviations. So will you expect the first data set to have a greater standard deviation or a smaller standard deviation? Greater.
It's B.
It's B, because I can't read. I can't read, I can't type, I can't do a lot. Compute the mean. Calculator based? Yeah. And standard deviation. So I'd have to put those into the calculator to be able to do that. Okay, I don't know whether this is right. Mean, let's see, 10, 9, 18, 28, 32, 35 divided by 5, 7. Yay. 7. Standard deviation. I cannot estimate that by hand. And this is going to be wrong, I'm sure. No, look at this. See what it does again? Points you towards something I never want you to do. But if you haven't got a calculator, you get to do. Not going to work. You said 3.39? 3.339, but they want the nearest hundred, so that's 3.34.
No, it's 3.39.
3.39. That's what you're telling me? And I just can't hear? Well, this was still wrong. So obviously my numbers are a little bit different, or someone made a typo in there. I don't care. It doesn't make a difference. I missed that question. So what happens if I multiply every value by 2? What's that going to do to the mean up here? Oh, I'm going to make an educated guess. 14. And I'm going to make an educated guess down here. Because if I make every value twice as large, doesn't that automatically make the mean twice as large? Doesn't that create twice as much difference between the mean and the other values once I multiply everything by 2? So if I multiply everything by 2, does it make sense that everything got twice as large? Then if the next problem says